Hi, I'm Andrew. Today I would like to teach you how to use a calculator to determine the intercepts and the end behaviors of a function. If you'd like to find a different method, like an algebraic method or something, please check out links in the description below. I'm going to leave there some links there. Well, I already said links, right? So I'm going to leave some links there that you can utilize in case you want to figure out or need a different way instead of using a calculator. All right. In any case, let's take a look at the question. So it says, what are the intercepts and the end behaviors of the following functions? And the first one they give us is going to be f of x is going to be equal to x raised to the fourth minus 81. So the first step, go to your calculator, literally just plug it in. So x raised to the fourth, then hit over to bring the cursor down, then minus 81. Now hit graph. Okay. Well, first of all, this might not even be what you're going to see. So let me just zoom. All right. Let me go to standard. This is probably what you're going to see. Now you're like, well, okay, but I don't even know what's going on there, right? It just looks like two lines. That's fine. You got to zoom out, okay? So go to zoom, hit number 2, and zoom out. Let's see if we can get and then hit enter. Oh, did I zoomed in? Sorry. You got to zoom out now, hit number 3. I think it's my first day using the calculator. So I'm going to zoom out twice. And as you can see, it's kind of coming down here a little bit. There's a lot going on all the way at the bottom. That's actually what the significance of this value, the negative 81. So I'm going to wind up fiddling with the window now. Just go out to negative 10 for x, and then go all the way to positive 10 on the x. Then for the y, you got to go down to negative 100 so you can see that point of interest. And then go up to, like, I don't know, let's go to 10 for now. Okay, let's see if this comes up a little better. Yeah, that looks a little better, right? All right. Let's bring this on in. Okay, so here's the readout from the calculator now. So now by using this graph, okay, we can figure out maybe what's the intercepts. Let's first do the end behavior, why don't we? So end behavior is it's what happens to this graph at the extremes. And you might have seen before that this graph is going to trail on and on and on and on forever in these two directions, okay? So let's see what's happening on the left-hand side. So as x is becoming more and more negative, this graph is going up to positive infinity, right? In other words, as x is approaching negative infinity, right? Negative infinity, the y value is going to positive infinity. Cool. And let's take a look at the rightmost part. As x is going further and further to the right, as x, in other words, is going to positive infinity, the y value looks like it's also going, all the way on up again, positive infinity. This is the end behavior. That's what they mean, okay? Now, the next part is going to be to determine what the intercepts might be. So you just have to kind of remember your scales a little bit, right? What you kind of utilized. So the intercepts are where this graph intersects the axes. So it looks like it intersects the x-axis at these two locations, and then it's going to intersect the y-axis, at that location. Remember, the vertical is y, the horizontal is x. So let's take a look at these x-intercepts. Okay, so let's write them down. So x-intercepts, it looks like, now remember my scale here I used, it went from negative 10 all the way to positive 10. And according to my scale, each of these tick marks represented a unit of 1. Okay, so I got to go 1, 2, 3, boom, I went 3 to the left, and therefore the x-coordinate there is going to be negative 3. All right, that's really the value. Okay, technically it's going to be 3, 0, because there is no y value to any x-intercept. So that's the coordinate for this one. And then how about this one? Well, same thing. You kind of see the symmetry, right? So the x-coordinate is going to be positive 3 in this case, 0. So that takes care of the x-intercepts, but how about now the y-intercept? Now, I kind of gave you a hint already before that it was going to be negative 81, okay? So it's going to be x value of 0, because you only got to go all the way down. And now this should be negative 81. Now that might be hard to tell from the graph, okay? Especially if you don't have it zoomed in over here, all right? But what we can do is we can utilize the table to help us out. So let's do this. So let's go to hit second table now, okay? And let's see if we can find these values. So when x was negative 3, let's bring this onto the screen, okay? Blow it up a little bit. Right. So when x is negative 3, y is 0. Anytime y is 0, that's always going to tell you the value of the x-coordinate of the x-intercept. Okay? So that's negative 3. That's great. Now what I should have done was I could have just clicked down a little more to get to positive 3, right? And there's the other one. Okay? As you can see, when x is then going to be a positive, 3, the y was 0. So that also tells me my x-intercept. So if you notice, that was good, right? Both cases we have proved that with the table. But now how about if I got to go to my y-intercept? Well, x has got to be 0, right? So I don't really know why I deleted all that. But when x is equal to 0, whatever the y value is over there is going to be your y-coordinate value, -81. That's what we said it was going to be, right? So notice how nice and simple that really is, okay? All right. So we took care of that one. Now let's go to the second example. So same thing. Let's try to breeze through this one, okay? So go to your y equals, clear out that function, and now type in negative x cubed. So negative x raised to the 3. Hit over to bring it down, plus now x squared. Okay, well, that would have been better if I hit the right button. And then plus 2x. Okay, hit graph. All right, so now this one looks like, okay, so let's go back to the standard window, all right, or standard zoom. So go to zoom, hit number 6, standard, so we can bring that all back in. So that looks like a reasonably okay picture. Let me see if I zoom in a little bit, if that's going to help. I'll go to number 2, hit enter. Yeah, that's actually really nice. Okay, that's really nice. So you're like, right, I wouldn't consider that really nice. It just looks like a graph, and, you know, I'd agree, but that's what happens when you do math all day. You see the beauty in non-beautiful things. Now, so let's take a look at the end behavior. So this graph is going to go on and on and on forever in that particular direction. Let me change the colors here a little bit. So I want to know what's going on at the end of this graph, right? So we can see as x is going more and more negative, y is becoming more and more positive. All right, so how do we write that? Well, we just say as x is going to negative infinity, the y value will be going to positive infinity. Easy enough. Then how about the rightmost part? Well, it looks like as x is going to positive infinity, y is now doing the opposite. It's going to negative infinity, right? So as x is going to positive infinity, the y value will be going to negative infinity. That takes care of the end behavior. Now let's take a look at the intercepts. So it looks like there's 3 points of interest. One here, and one here, okay? All 3 of these points represent an x-intercept because it crosses that x-axis. But only one of them represents, this one in particular represents a y-intercept. Okay, and you should only have, by the way, one y-intercept. Otherwise, it won't be a function. Now, okay. So let's write down the coordinates of those x-intercepts. So let's write x-intercept. All right. The coordinates of this point, now this might be a little hard to kind of, but each one of these tick marks represents 1 unit. Okay, so here is 1 unit. That's going to be a -1, comma 0. This looks like it's at the origin, right? So that's going to be 0, comma 0. And then last but not least, this is going to be a +2, okay? +2, comma 0. All right, so that takes care of those intercepts. Now let's do the y-intercept. So again, it was this particular coordinate. The y-intercept there is also going to be 0. It's going to happen at 0, 0. All right. Now those are all the values. That's how you would use a calculator. If you want to confirm it, just use your table now. Go to second table. All right. And let's see if we can find these coordinates. When x is -1, is y there 0? Yes, it is. When x is going to be 0, is y 0? Yes, it is. When x is 2, is y 0? Yes, it is. Those were all the x coordinates. And x-intercepts. And then when x is 0, y is 0. In other words, when y is 0, x 0, that's also a y-intercept. That's all there is to it, ladies and gentlemen. Calculator is a nice, useful tool. All right? So, guys, thanks so very much for watching, and I appreciate it. And girls, by the way, right? I don't know why it's always such a common saying to just say guys, but you know what I mean. Thanks again for tuning in. I really appreciate it. I do hope this video helps, and if you can help us out, like, subscribe, and tell your friends. All right? We really appreciate it. I'll see you in the next video. Take care.